Well, good morning. How are we doing out there today? Everybody all right? Good. So everybody's been to all their, well, maybe all your classes. Some of you might have like a night class tonight or something like that you haven't been to yet, right? I don't know. So most of your classes, hopefully your week's going very well. All right. I'm not seeing Kingsport over there. Are you all seeing me?
Yeah.
Okay. Thank you. Thank you. Just wanted to check. Yeah, I'm not seeing them though over here. So anyway, last time we talked about the syllabus. We went over that. Did y'all think of anything you had meant to ask about the class? Anybody come up with any problems or questions you wanted answered? Yes, go ahead. You'll need to press your button, though, okay? Thank you.
Did you get my email?
What's your name again?
Rachel.
I don't recall one. But is it a question you want to ask now or after class? Either way, it's fine. I mean, it's up to you.
I tried going on to my stat lab, or my math lab, I mean,
Mm-hmm.
and it kept wanting me to buy the thing, even though I had a math class in the spring.
Okay, so did you have a math class that used this textbook in the spring?
No, not this textbook, but it's my math lab.
Okay, had you used the code before then? Had you used the My Math Lab? Were you already registered into My Math Lab? Okay, but it's under a different book, right? Okay, it won't let you use it, so you'll have to get a new one. I'm sorry. Yeah. So the My Math Lab thing, it is good for a year, okay? So, but it's only good to use with the same book that you had used it with, that you'd registered with before. So, for example, if you had taken the 1710 math class before this, where they do the first part of the book, then it should still work for this class. If you had taken 1720 before and for some reason we didn't finish it, and you're taking it now, it should still work as long as it's within that time frame of a year and it was with the same textbook. So sorry about that, though. So if you did do that, then you don't have to buy a new one, if you're in one of those categories I was talking about, because there's a place on there that it tells you can add a new course or something like that and put in our new course ID. Okay. What else? What other questions? That's a good question we needed to clear up. I still can't get my math lab, that website, to come up on this computer, so I guess I'll talk to OIT or somebody about that. I don't know, because it's not working in here, in this classroom. All right, other questions?
How soon are we going to need a scientific calculator?
How soon will you need a scientific calculator? Well, we're not using anything on the first test, so after that, you should be fine through the first test. So when would the first test be? I don't have that date down yet, but normally we cover about a section a day in the textbook, approximately, give or take a little. It'll probably be, about 3 weeks at least before we have a test, okay? Just to give you a generalized idea. Any questions from Kingsport? All right, if anybody comes up with a question, just let me know. I'm going to run back through the roll just for my purpose and just to kind of still, get you on that microphone there for a minute. I don't want anybody to be afraid to push that button on the microphone. Go ahead, you have a question.
How often will we be just using the textbook for practice problems?
Right, we will be using the textbook for practice problems. Sometimes in class I'll bring up a problem. I'll write it out for you, though, or pull it up on the screen or something, okay? So mostly the textbook will be for your use for practice problems. I try to paraphrase the textbook. Okay, I'm not going to go and write word for word up here what it says in the textbook because you can read that stuff on your own. I'm just trying to make it a little easier to understand for you, okay? Anything else there so far? Okay, let me run through the roll here, and if you'll just let me know you're there, but do use your mic so that everybody can hear that, that you're here, okay? All right, Bo Beck.
Here.
Okay, thank you. Douglas Concannon.
Here.
Amelia Kukulowska.
Here.
Brandon Delgado Adame.
Here.
Tom Ellswick. Tom Ellswick. All right, Juan Gisbert.
Here.
All right. Jamie Kinchlow.
Here.
All right. Sydney Lawson.
Here.
Aaron Mayer.
Here.
Rachel McCauley.
Here.
Larry Moore.
Here.
Veronica Morlock. Veronica Morlock. Cheyenne Mullins.
Here.
Okay, thank you. Michael Mullins. Grady Peters.
Here.
Okay. Jacob Porter.
Here.
Chance Pritchett. All right, Chance Pritchett, no. Brent Rathbone.
Here.
Evan Riley.
Here.
Gerald Rivers.
Here.
Stephen Scheidler. Stephen Scheidler. Kyle Seavey.
Here.
Zach Stillman.
Here.
Austin Skelton.
Here.
Okay, thank you. William Thacker.
Here.
Okay. Jonathan Wright. Tom Zaleski.
Here.
Okay. Anyone else? I did not print out a new roll sheet today, so if you added between Monday and, between Tuesday and today, then I don't have you on my roll sheet just yet. I mean, it's probably on the computer, but I haven't gotten it off. So is anybody else here that I didn't call your name today? Anyone else in Kingsport that I didn't call your name? I'll take that as a no then. Okay. All right, so what I'm seeing on my screen for Kingsport over here, it says recording. So I guess we're recording. All right, last time what we started doing was working in that chapter 6 a little bit, and we drew up a circle. You got to pretend that I could draw a circle. I remember that. Pretend that I could draw a circle that had an actual center in it that looked right. It probably doesn't. It may never. Nothing in this class is ever drawn to scale. I'll tell you up front. Yeah, I try, but it might look
Jamie?
that way, but it's probably not going to be. Yes. There we go.
What did you say about Kingsport and recording?
Okay, until just now when you asked me that question, I was just seeing where it said recording on the screen. It was just a black screen, said recording, and I could not see you all. But now I see you all, so I'm glad we see you now. Yeah, I don't know what it was doing.
Okay, we got gremlins this morning, so we had a. Oh, someone has to
okay,
speak
so
to knock that off. Okay, well,
Okay.
I'll remember that in the future then.
Okay, so you can speak to me in the future. Okay, thank you. I appreciate that. Yeah, I didn't know what was going on either. But I like to be able to see you all, so that helps me out. So thank you. Okay, so we had started talking about chapter 6. I do kind of flit around, you might say, a little bit in the first part of chapter 6. Okay, I may not do all of section 1 at that exact time, but it will be there. It'll be information from chapter 6, okay? So I just want to make you aware. I'm not making this stuff up that I'm telling you up here. I promise you. I didn't just, say, what can I tell them today? Let's make it, something real far out for them. All right, so let's go back to kind of what we were looking at. We started talking about angles. We went over some basic vocabulary for the angles, so we'd know what we were talking about. We just reviewed some basic geometric terms last time. I don't remember if we mentioned or not that if we have an angle, and it's coming up on the screen, okay, go ahead.
Is this still chapter 6?
Oh, yes, definitely. We barely started chapter 6. Let me tell you, chapter 6 is long. It's going to take me more than a few days even to do chapter 6, okay? Chapter 6 has a ton of material. When we have an angle like this right here, we said an angle, you know, is where two rays join together. And we had the initial side and the terminal side. And we said we're going to measure it in this direction. Okay, now one problem you might hear me running into, I have this class again on Monday, Wednesday, Friday. Okay, sometimes I get a little off track to which group I'm talking to. So if I tell you something and all, you're like, you didn't tell us that, you know. Okay, I try to make myself a little bit of notes where I kind of know what I've said and not said yet. But every now and then, you know, I'll get it a little confused, I'll just tell you. So I'll try not to have that happen. But if I tell you something and I'm expecting, you know, that I've already said that, you might say, it wasn't us you told that to. Okay, but usually we're okay on this stuff. So when we measure an angle up there at the top, I'm measuring in this that counterclockwise direction. That's going to be a positive angle measure. Likewise, I might repeat some things for the same reason. Okay. And this one here, if I measure this direction though, in the clockwise direction, it will give me a negative angle measure. So hypothetically, this one could be like 30 degrees. I'm not saying it is. Okay, again, maybe not drawn to scale. I'm not actually measuring this thing here. But a 30-degree angle there and a negative 30-degree angle here, okay, is how we would be looking at that. It's all in how you measure your angle, what you're talking about. So we want to know, you know, how to get to these angles, whether they have a positive or a negative measurement. All right. Let me think where else we were the other day. We talked about converting from degrees to radians. We started looking at a circle and seeing, you know, how pi radians is equal to 180 degrees. Okay, we did talk about that, yes? Yes, good, okay. We drew up an XY coordinate system. We drew my kind of circle with the center there. Yeah, that looks very off today. So we're going to start here with 0 degrees. And this is being my initial side right here where I'm going over that part of the x-axis in blue. If I go up to here, I'm at 90 degrees. If I go all the way over here, I've got a straight angle now, so I'm at 180 degrees. Going around to this lower part of that y-axis, now I'm where? 270. I think we labeled all the degrees around here, didn't we? Last time. And if I come all the way up here, well, back up to where I started, now I'm at 360 degrees. Okay. Now, note, we started at 0 degrees, we circled around, we came back to the same place, but now we're at 360 degrees because we've been around the circle. Okay, we've been around that central angle. Central angles are angles that, you know, have their vertex at the center of the circle. So that's what we're looking at here. We also said last time, or I think we said, that the 30 degree, 45 degree, and 60 degree angles and all of their related angles are what we're really, really interested in. We're going to be highly interested in those angles in here, as well as the ones we just put up here. So let's put those on here as well, because we'll be using those here in a minute. So here's going to be my 30 degrees, 60 degrees, and I've already got 90. Right now I'm dividing up by 30s here. So 120, 150 degrees, 210, 240, 270, where are we now? 300 and 330. Okay. We're very interested in all those angles. We want to have those angles up here in our head, pretty much anything about them that I tell you in here. I'll be telling you a lot more information about these angles. Now, we started looking at radians last time. We said that pi radians is equal to 180 degrees. Okay? Pi radians is equal to 180 degrees. So I'm going to put some radian measures up here. 0 degrees is 0 radians. Pi radians is 180 degrees over there. What does that mean 90 degrees was? Pi over 2, or half of pi. And down at 270, that would be 1 and 1/2 pi, but we don't write it that way. We put 3 pi halves, or 3/2 pi. Okay. When I get back up to 360 degrees, what's that one going to be? 2 pi. Okay. So the things I'm putting on there now in black are my radian measures. All right, 30 degrees. I think we talked about that one, but let's go back for just a moment and use that formula as well, just to see kind of how that works on here. The formula said that if we have the number of degrees and we multiply by pi over 180, we'll get the radian measure. Okay, I ran out of space there. Okay, the degrees times pi over 180 is equal to the radian measure. So let's take our 30-degree angle times pi over 180. And 30 divides into itself once, into 180 6 times. So that gives me pi over 6 radians is equivalent to that 30 degrees. Okay. Now I think we already knew that, didn't we? We might have already known that, because if you look at where pi is over there, see where pi is? If you look at where pi is, 30 degrees is a sixth of 180, or 180 divided by 30 is equal to 6. So 30 degrees is equal to 1/6 of that 180. So therefore, it's also 1/6 of pi, or pi 6 is the same as 1/6 pi. Okay? Yeah, go ahead. You'll need to do that so I don't have to repeat. Okay?
Why did we use pi over 180?
Why did we use pi over 180? Okay, let's go to our other part here. Okay. Whoops. We put up yesterday that pi over 180, well, let's start here. 1 degree is equal to pi over 180 radians of a radian. That's just a, a decimal amount there. And 1 radian, though, is equal to 180 over pi degrees. Okay, so that's where our conversion comes in there. So we'll take degrees times pi over 180 is equal to radians. And radians times 180 over pi equals degrees. Okay, so there's our formulas to convert from radians to degrees to radians. Okay, you're welcome. No problem. So that's, I guess, maybe the real basis where some of this comes from, with the radians and the degrees and their connection here. I kind of like telling you about the, pi radians is equal to 180 degrees, because then I think you can see, for these basic angles, we're going to use what part of 180 they are, and therefore what part of pi they would be equal to. All right, I'm going to go back over to my circle here for a minute, and we're going to label these around. Even if we labeled them last time, let's label them again, because I want to make sure that we're seeing what's happening here, how we can count those angles. I don't know how many times people have told me, I teach calculus sometimes as well, how many times people have told me that they had to know the unit circle, but they never really understood what was going on with that thing. Okay, yeah, it was there, they're familiar with it, but they don't know what's going on with it. So I'm trying to help you with that. Okay. All right, so we have 1/6 pi over here at the 30-degree angle. This 60 degrees is actually going to be 2/6 pi. I'm writing 2/6 pi, but really what we want to call it is pi over 3, right? Essentially, it's 2/6 pi, because I'm just counting. So I've got 1/6 pi, 2/6 pi, 3/6 pi. We've already labeled that one as pi over 2. We've already done the labeling there. 4/6 pi, then would be the next one, because I'm just counting. 4/6 pi, though, is equivalent to 2 pi over 3 for 120 degrees. Then I have 5/6 pi. 6/6 pi is already labeled, because that's just pi. I come down to 210 degrees. That's going to be 7/6 pi. This one here is 8/6 pi, but that one's got to be simplified. 9/6 pi, it was already simplified, right? 3 pi halves. 10/6 pi, there for the 300. 11/6 pi, and then 12/6 pi is the 2 pi. We're just counting around on all these 30 and 60 degree angles. We can get those labeled with radians just by doing a count there. 1/6, 2/6, put pi with all of them because they're that part of pi. Does anybody have a question on that part? Are we good so far? Does anybody know what I'm talking about seeing the unit circle before but not really seeing where these things came from? Yeah, some of you have had that happen. All right, so now the other types of angles we said we were going to be interested in here are the 45 degree angles and the ones that go along with them. So 45 degree angles, let me put this one in. 45 degrees is in between here. And then, so 45 plus 45 is 90, plus 45 is 135, plus 45 is 180, plus 45, we're in between here now, it's 225 degrees, and plus 45 is 270, plus 45 is right here in between these two, 315 degrees, and plus 45 is 360 degrees. So I've added in some black lines indicating the terminal side of these particular angles. Okay, the terminal side of the 135 degree angle. So 135 degrees, in other words, is from there to here, it's this measurement. Okay, that's what we're looking at there to get over to that part. So 45 degrees is what part of 180? It's a fourth of it. So 45 degrees is going to be equivalent to pi fourths in radians. Essentially, again, we're counting. Okay, this time we've got to count with a different type of fraction, though. We've got 1/4 pi. Then we go up to the next one, which is the straight up 90 degree angle. We've got 2/4 pi. We've already labeled that. That's pi halves. Then we go to the next one over there in the second quadrant. 135 degrees is 3/4 pi. Then I go down here to the 180. That's 4/4 pi, but I've already got that labeled as pi, but it is because it's 4/4 pi. So what must 225 be? 225 degrees?
5/4 pi.
Right, 5/4 pi. And then 6/4 pi is that one, that 270 degree angle. 6/4 pi is the 3 pi halves radians. And 7/4 pi is up here at the 315 degrees. And then 8/4 pi brings us back to 2 pi. So we've got two counts we're doing around here to get these basic angles in. We're doing the ones that count 1, 6, 2, 6, 3, 6 pi, all those. And then we go through starting with the 45 degree angle with 1/4 pi, 2/4 pi, and so on all the way around. We've got our angles labeled now in degrees and in radians, right? Okay, so one thing in this first part of the textbook in section 6.1, we have two formulas we're working with that require that the angle measure must be in radian measure. The reason is most of you are more familiar with degrees than you are with radians, so we're trying to get you a little bit more familiar with those radian measures so we can get more comfortable with those. Again, you may want to use these formulas. Okay, they may come in very handy here. Let's look at one problem from this part. We said yesterday we're going to be able to find the arc length with this formula here, S equals R theta, where we have a circle, we have a central angle here. The arc length is going to be this arc that's sectioned off by the circle. The radius is the distance from the center of the circle to a point on the circle. Okay. And then theta is the angle measure right there. Okay, that's going to be our theta value, our angle measure. So we have here arc length equals radius times angle measure. Now, in this formula, in order for it to work, the angle measure must be in radians. Okay. So these problems are over on page 360. I'm going to ask you to do some for practice, before you come back on Tuesday. I'm going to put one up here right now. Let me find where one is. Let's see. Let's go down to number 78, and this is on page 360. I'll put here. The radius is equal to 3 meters. Theta is 120 degrees. What is the arc length? Is asked, okay? So we know the formula, S equals R theta. Problem here is that the angle measure is given in degrees, and we need for it to be in radians. It happens to be one of those angles that we had labeled on that circle we just drew. Now, if we didn't, or if maybe it was 123 degrees, something like that, we might need to actually calculate it out, with the formula. But we already know what this one is. This one's actually equal to what? So reduce it for me. Okay, so 2 pi over 3. 120 degrees is 2 pi over 3. Go back over here and look. Here's your 120 degree angle going from here to there. It's 2 pi over 3. Okay, so we do want to use those in, their simplified form there. So now we have S equals 3 times 2 pi over 3. What's that going to equal?
2 pi.
It's just 2 pi, right. So S, or the arc length, is equal to 2 pi. Now in your textbook on this part, they will use a calculator and round. You can do that if you want to check your answer with. When I give this on the test, since I said no calculator, I want you to leave it 2 pi. Okay, just leave it in that form. In some ways, that's easier, right? Okay, yeah. So just leave it 2 pi when we do it on the test. Now, what about units? What kind of units would this be in for this arc length? 2 pi what? Is it 2 pi radians? The angle was measured at 2 pi thirds. Let me ask you this. If I've got a circle up here, this rim of my coffee cup up here, okay, and I want to measure it, or measure a piece of it around here, what would I measure that in?
Would it be minutes?
No. How could I measure this? If I want to know even this, how far around this is. What's that called, the distance around a circle? What's that called? Circumference. The distance around the circle is a circumference, okay? It's a distance. What if I took a string and laid it here and very carefully fixed it around the edge, and then I laid it out to measure it? How am I going to measure it?
Inches.
Yeah, something like inches, something like that. All right, my radius here is measured in meters on the problem we're looking at, right? My radius is in meters. My arc length will also be in meters then, okay? That's what we're comparing it to here. So that's going to be in meters, even though I know when we say 2 pi, we want to think radians right off the bat because we were working with that sort of thing. Yes, go ahead.
So as a radian, is that where R is equal to S?
I'm sorry? Ask me that once more.
Like it says S equals R theta. So is a radian where your arc length is the same as your radius?
The radians is just going to be your central angle measure. Okay, this angle that we're forming here, well, that didn't work. Right here in this, that has its vertex at the center, okay, we're measuring it in radians or degrees, just that central angle itself, okay? So it's an angle, but that arc length, it's actually a length there that we're looking at, okay? So it's going to be measured in whatever units your radius is measured in. Okay, does that help on that a little bit? Okay, just to kind of try to, let us see what's going on with this here. Now, the other formula we're going to use here has to do with the area of the sector of the circle. So what's a sector of a circle? We talked about that a little bit last time. What's a sector? Is it what? It's a part of the circle. Okay, so where's the sector up here on my drawing? Okay, it's that pie-shaped area, right? That piece that we've marked off there. So that's the sector, all this stuff right here, okay? That's the sector. So if I want to look at the area of the sector, I have another formula I'm going to use there. 1/2 r squared theta. Again, theta has to be in radians. And again, theta is still that central angle there, okay, that we're working with. 1/2 r squared theta. We'll just use this same information that we already had up here and work with it and see what the area of the sector is going to be there. So the area equals 1/2. The radius was, what, 3? So 3 squared. Theta, we've already put it in radians. That's 2 pi thirds. We're not using a calculator. So what do you get? 3 pi. All right, good. So we have 1/2 times 9 times 2 pi thirds. And we can do some canceling here. The 2's cancel. 3 goes into 9 3 times. So it looks like we get 3 pi. Is everybody getting 3 pi? See where that comes from? Does anybody have a question on the 3 pi part? What's the question? Ask everybody, please. Okay.
Did you just reduce the 9? Or
Did I reduce the 9?
uh-huh.
Yeah, here's what I'm saying, okay? Right here. This 3 that I marked out goes into itself once, divides into itself once. It divides into 9 3 times. The 2's divide, 2 divides into itself once. So that's what I'm working with there. You could have come straight across and said it's 18 pi over 6 and then reduce that to 3 pi if you want as well. It works either way. What's the units on the area here? What is it? Meters squared. Meters squared. Okay, so meters squared. Or you might put square meters, some of you, right? One or the other. Area is always measured in square units. That's not really part of this class, but it's just something we should know. So we'll put that out there too. That's free today. Okay, free information. Sometimes I'll throw it out there. So, it's old stuff though. All right, so we've got 2 formulas here we're using. One is to find the arc length of a circle that's an arc length that's been set off by a sector of a circle. That's all right. The other is to find the area of a sector of the circle. Okay. All right, so in this first section, then they're having you convert from radians to degrees, degrees to radians, and use these 2 formulas. That's what we're going to be working with in the first section. Don't let me forget to give you some practice problems before we leave here today on that. But we're going on into section 6.2. Okay. For now. There's some things in 6.1 that we may come back to a little later, but for now we're going on into 6.2. So in 6.2, that's working a little bit more with that circle idea there. Well, 6.2 and 6.3. 6.2 is talking about the unit circle approach. We've looked at the circle here. They're calling it a unit circle. What does that mean? In a unit circle, the radius is equal to 1. Okay? That tells me that when I go from the origin here, the center, out to this point right here, I've gone 1 unit. If the radius is 1, up to here, that's 1. Over to here on my axes, because I'm on my axes, I'd be at -1. And down here, I'm at, that's -1 on the y-axis. Okay? That gives us the ability to label these points where the circle is hitting on the axes. We have to remember ordered pairs. Go ahead.
Wouldn't the one at the top of the y-axis be a positive one?
It is +1. That was my little notch. I'm sorry. I'll take that off. That looks confusing, huh? It's definitely +1, yeah. I was just kind of notching the coordinate. Does that make sense? Okay. So what we have here then, we have the ability to label these points with their ordered pairs. So let's put those in. So I'm going to extend this a little bit here. This one over here, now I'm putting a point there. What's the coordinate for that?
1, 0.
1, 0. Good. Actually, let's do it in this blue so we can see. The blue doesn't want to write so well, so let's go to black. All right, so what about that one up there at the top? 0, 1. Over here? -1, 0. And down here? 0, -1. We're labeling ordered pairs, okay, of x, comma, y, ordered pair idea. Now, before when we labeled the circle, we had labeled these with degrees and radians, telling, what we were getting as we go around with the angle measure at these places. We know we also had some other angle measures in each quadrant here. When I talk about quadrants, what am I talking about? What's quadrant 1? Which one's quadrant 1?
Upper right one.
Okay, good. Upper right. So here's quadrant 1, 2, 3, and 4. We usually label those with Roman numerals, but we just need to know, how they're labeled. They're always quadrants 1, 2, 3, and 4 in this order. Okay. If I mention something about an angle in quadrant 2, you'll know where I'm talking about. Now you'll know where we are. Now we had these other angles in here. We had that 30-degree angle, which was pi over 6. 45 degrees was pi fourths. And up here, 60 degrees is pi thirds. Okay. Well, where those angles, where that terminal side is hitting on this unit circle, we're going to be able to label those ordered pairs as well. That's another thing we want to know about these angles. That's what's going to help us know about some of this trigonometry here. So here's what we have. We have this point right here, point there, point there. We want to know how far over and how far up we have to go to get to those points, to get the ordered pairs. I'm going to start with what's probably going to be the easiest one for you, and that's the 45-degree angle. Some of you may already know these, and just bear with us if you do. I keep getting my pen hung up here. All right, so the 45-degree angle is what we're going to start with here. On it, let me take it out of the circle a minute, okay? So I'm going to come down here. Here's my 45-degree angle. There's my center of the circle where I just picked it up and removed it out of the circle. Okay. Out here's where it, it was hitting on the circle right there, right? That's what we're looking for. X, Y, whatever the coordinates are. To get those, though, I'm going to drop a perpendicular line down to where my radius was, okay? So what I'm looking at, here's what I just pulled out of this circle. This right here. You see what I'm pulling out there? So I'm forming a right triangle. Now in my right triangle that I just formed here, let me draw it down here as well. I know that the radius here is equal to 1 because I said this was a unit circle with radius equal to 1. So I know that this part right here is the radius would be equal to 1 coming from this right here. The radius is all the distances from the center all the way to the point on the circle. What I don't know here is what is this value for my x, what is this value for my y. That will give me my ordered pairs to get up to that point. Ordered pairs are just a way of giving directions. Okay, that's what they are, giving coordinates. You all used ordered pairs before when you didn't even know they were called ordered pairs, maybe. You used it, well, before we had maps on every phone and gadget we had to use, like real maps, right, an atlas or something. You had to look up, I want to go to Myrtle Beach, and it says it's at C8. So I have to find where C and 8 meet each other, and there's where Myrtle Beach is. You are looking at me like, I don't know what the heck you're talking about. Some of you, okay? Well, we used to do that, okay? Some of you know what I'm talking about. Some of you played a game called Battleship years ago, maybe, right? When you were a kid, Battleship, you have to give those coordinates where the ship is, right? So you can try to sink your opponent's ship. That's, you know about that one, I see. All right, good. We're good then. Okay, so we have this one side on my little pulled out triangle over there. Which side is that on my right triangle? What's that side called on a right triangle? Where I say r equals 1. Okay, it is the terminal side of my angle. Yeah, that's true. But in my triangle, it's my hypotenuse. Okay? In a right triangle, we have a hypotenuse. It is the longest side of the right triangle, and it is also the side that's always across from the right angle. Okay? Now, we know this angle down here is 45 degrees. What does that tell us about this angle up here? It's also got to be 45 degrees because we said last time that all angles in a triangle add up to give us 180 degrees. Okay, so we've got two angles that are equal to each other. If the two angles are equal, what does that mean about the sides across from them? Yeah, they're going to be equal to each other, these two sides. So this is the one I was calling x. This is the one I was calling y, right? We know that in this right triangle that x squared plus y squared equals r squared, don't we? Why do we know that? Pythagorean Theorem. Okay. But we're saying that x and y are equal here. So if x and y are equal, then doesn't that mean that x squared plus x squared equals r squared also here? I can call one of them the other. So x squared plus x squared equals, I know what r is. R is 1. So equals 1 squared. That would be 2x squared equals 1. I'm trying to figure out what x is, because if I know what x is, then I know what y is. X squared will be 1/2. If x squared is 1/2, I have to get x. So x is going to be the square root of 1/2. Square root of 1 over square root of 2. Well, let's take that down a little lower. Oops. That's going to be 1 over the square root of 2. And because the textbook normally does, and for you to check your answers and so forth, I'm going to go ahead and rationalize that. Okay, what does it mean to rationalize? Do you all remember from algebra? Okay, multiply by the square root of 2 over square root of 2. Why am I doing that? That's right, but why am I? Get rid of the square root in the denominator. So to rationalize, I want to get rid of the square root in the denominator here. Okay. So I'm going to multiply by the square root of 2 over square root of 2. That will give me the square root of 2 over just plain old normal 2. That's what x equals. And in this case, that means that's what y equals also. Okay. Now, you're not going to have to derive that every time. That's just how we get there. Okay. I'm just trying to tell you, we didn't make up these points. Okay. This is where they're coming from. These are the ordered pairs that get us to that place. So on a 45-degree angle, or pi over 4, the ordered pair where this coordinate is will be called square root of 2 over 2, square root of 2 over 2. That's the ordered pair associated with the point where the terminal side of the 45-degree angle hits on that unit circle. Those have a lot of meaning for us in trigonometry. Go ahead. Question? Are we okay? Kingsborough, you all okay over there? Now I can see you, so you can shake your head. Okay, great. Thank you. All right. So those are our coordinates there. Well, we need to look at the 30 and 60-degree angles, but I think I'm going to need a new page. This one's a little messy, isn't it? You are going to memorize that square root of 2 over 2, square root of 2 over 2. Okay, that's why I say you don't have to derive it. I just want you to see where it was coming from. But you're going to have that up here. That one's not too bad. They're the same value. Let's look at the 30 and 60-degree angles. I got to draw my XY axis. Draw a circle. We'll just put the 30 degrees on it right now. Okay, there's my 30-degree angle. If I do like before and drop a perpendicular down to the x-axis, this is the point I'm looking for the coordinates for right there. That's what I want to know, what goes in there. What's my other angle up there on this triangle? Has to be 60. So this is a 30, 60, 90 triangle. I also know the radius here. The radius is 1 because I'm still in a unit circle. Okay, radius is 1. Does anybody remember how 30, 60, 90 triangle sides relate to each other? This would be something you would have done in geometry class a long time back, maybe. Anybody remember that?
Yeah.
Yeah? What is it? Kind of remember? You remember there's some relationship, right?
Yeah, there's some like a 30.
Okay, y is 2x. Okay, so what part are we talking about there? The angle, the hypotenuse is going to be 2 times the side across from the 30-degree angle, okay? So let's put that down here. Hypotenuse equals 2 times side across from 30-degree angle. So we know that then. Okay, that's in a 30, 60, 90 triangle. So if the hypotenuse is 2 times the side across from the 30-degree angle, what must the side across from the 30-degree angle be? This side right here. It should be 1/2. 1/2 of that radius, which the radius is 1, so it's just 1/2. And 2 times 1/2 is 1 for that hypotenuse value. Okay. If we have this information, then there was another relationship for that other side, but a lot of people don't remember that. But we could use the Pythagorean Theorem now and get that other side, couldn't we? So we could say, and this other side is x, so x squared plus 1/2 squared equals 1 squared. So x squared plus 1/4 is 1. That means x squared equals 1 minus 1/4 is 3/4. So x is going to be square root of 3 over the square root of 4, which is the square root of 3 over 2. Why are we looking at that? We're looking at that just to see where these values come from for the ordered pairs. Okay, some people may not really show you where they come from, but I don't know. I hope there's some merit in it. Maybe there is, maybe there isn't. But so we've got here, the coordinates here are square root of 3 over 2, 1/2. The coordinates where that 30-degree angle, that terminal side, is hitting on our unit circle. That's what we're looking at there, the coordinates. Go ahead, you had a question?
Yeah, wouldn't that be 1/4 since it's 1/2 squared?
Where are you looking at? I'm sorry?
In the Pythagorean Theorem.
Where I had x squared plus 1/2 squared equals 1 squared. And then this line right here? Yeah. Okay, that is 1/4, right? 1/4? Okay. Are we okay? Or am I missing the question there?
I was thinking that the point on the graph where it would be 3 squared over 2, 1/4.
No, we had already found that the y value is 1/2 because of this part here. The hypotenuse was 2 times the side across from the 30-degree angle, which means that would interpret just to the side across from 30-degree angle equals 1/2 the hypotenuse. Okay? 1/2 times the hypotenuse will give you that side across from the 30-degree angle. So we've got square root of 3 over 2, 1/2 for those coordinates right there. Now, you're going to have no trouble telling me what these coordinates are going to be up here. Yeah, for the 60-degree angle. Whoa, I'm getting carried away here somewhere. There we go. Okay, so you're telling me the coordinates are the reverse, right? Okay, so 1/2 square root of 3 over 2. Because all we've done is we've taken that 30, 60, 90 triangle that we started with up there, and we've turned it up, you know, just kind of turned it around, haven't we? We still have a 30, 60, 90 triangle. Go ahead. Ask us all.
I thought x goes first before the y, like on the coordinates. So wouldn't
X goes before y, correct? So where are we looking?
Wouldn't it be like square root of 3 over 2 first before the 1/2?
It is right here.
Oh, okay, I didn't see that.
This is for the 30-degree angle, okay? This one up here is for the 60-degree angle. So that's for the 60-degree or pi thirds angle, okay? So look at what we have here on this, okay? Look at what we have here. Let me walk over here just a minute to the things, see if I can reach this. Okay, I think I'm good here. All right, so what we have right here is we've shifted that triangle around, haven't we? Okay, we've shifted it around, and what we've got then, if you remember on your coordinates, we're going out square root of 3 over 2 units and up 1/2 for this one that's connected with the 30-degree. But to get up to that point up there that I can't reach, okay, we're going over just halfway, and then up square root of 3 over 2. Square root of 3 over 2, that might not have a lot of meaning for you. Square root of 3 over 2, what's that equal to? Well, you'd have to use your calculator to get an approximation, I guess. But it's less than the square root of 4 over 2. What's the square root of 4 over 2? 1. So it's just slightly less than 1. So where we have to go out closer to 1, we're going out that larger distance, square root of 3 over 2, right? And then just going up a little bit, up 1/2, which would be less than that square root of 3 over 2. Hey, did you have that decimal for square root of 3 over 2? Is that what you were telling me? What is it? 1.73? Okay, so see, it's close in there. Good. Does that help a little bit on seeing how those coordinates work? Okay, so, well, we want to get these things in our head really well here, because here's what we want to see. Let me go over here just a minute. I didn't log in today, but let me log in for a minute. So I've put on your D2L site one of these unit circles, okay? I have you a blank one. I have one that's filled in. Let me go to those. Spring, we're fall. Where are we? When you go into your D2L site, for all of you, it's going to say 1720-501, whether you were actually 501 or some other section number, okay? Because we had 2 section numbers, but we put them together. So it's all going to say that 501, so don't worry with that, but just in case. And I don't think I told you, but down here's where it tells you how to watch a recorded class, okay? So that's right there on your front page of D2L while I'm there. Hey, I like class so good today, I want to watch it again, right? Well, there's class notes. There's where I posted, that's where I posted the notes that we had on Tuesday. Okay, so they'll always be there for you. Under handouts, so that's where I was going to go. Under handouts, I have this unit circle. Let me download the unit circle. Now, I've been drawing this thing. Let's see, where's the place where I can move it around? I need to move it around.
So you got the answer selected already?
Right, but is this what I'm looking for? Yeah, there we go. So I've got this thing on here. Here's what we've been looking at over here in this first quadrant. Do y'all see that? See what we've been looking at? Here's what we just did. Now, they've got those slashy fraction bars there. I do mine more, horizontal. But on this thing, we've got our degree measures. We've got our radian measures. This radian measure is kind of at the wrong place. I don't know why that's like that, but let's do red. 2 pi should be right there. 0 coordinates there with the 0. Okay. Now, you see though out here's the coordinates. The coordinates are for this point right there where the unit circle hits, where the line, the axis hits on that unit circle. The points are here. That's what we're labeling here with these ordered pairs. Okay, this. Those are the ones we just found. Don't worry about anything else on there right now where it says about tangent and all that. You don't have to worry about that just yet. We'll get there. We all obviously have coordinates that correspond to those other angles that we labeled all the way around the circle. So what's going to change? Well, in the second quadrant, your x's are negative and your y's are positive. They're going to have the same coordinate values, just we got to watch with our signs, negatives and positives there. So all the x's will turn to negative, the y's to positive. You see though how that's symmetric? Everybody seeing that symmetry? Look at this one here compared to this one right there. So we've got the symmetry going on. Okay. Then we also have the third and fourth quadrant. Let me move this down just a little bit. Same thing here. Okay, we've got those same coordinates we're using, but here it's going to be negative, negative, just like when you studied ordered pairs in the past in your algebra class somewhere along the way, and positive, negative over here in the fourth quadrant. So the signs are labeled accordingly there. The coordinates are labeled accordingly, okay, to what quadrant they're in. You want to get this stuff in your head here. You want to memorize this stuff. Do you really have to memorize all the way around the circle? I don't think so. I think if you know that first quadrant, you can adjust your signs and go all the way around, can't you? You might want to look over it a little bit, though, and see. I was going to tell you something else here. It just left me. I don't know what it was. We also have the coordinates out here for, you know, these values as well. The angles that are here, like the 180, the 0, 360, the 90 degrees, the 270 degrees, those are called quadrantal angles. Okay, because they're not really in a quadrant, they're on the borderline. We can't say that angle's in the second quadrant. Okay, it's not really. It's just there. So you've got this here. You can look at this. You can print it off, maybe use it while you're working with your homework, or not print it off, to leave it on your screen. You know, that's fine too. Over here then, back on the D2L site, we also have under handouts a blank unit circle. So here's what it looks like. Well, this is just how it came. Fill in the unit circle there. Okay, so here's what it looks like. It has a place for the degree measure, the radian measure, and the coordinates for the points. That's what it has. So you can practice. Make sure you know that. Why would you want to practice? Well, one thing, I want you to know this. That's thing number one. Okay, point number one. Point number two, this will be a question on the test. You'll have to fill this thing in on your first test. So I'm telling you now, that's going to be on the test. Know it. We won't have a test for at least 3 weeks. Okay? You got time.
That'd be just one question.
Well, I think it might count a little bit more. You know, it'd probably be one question, but you know, it might count a little heavier. Okay? It's got lots of stuff on it. It's going to take a few minutes to do it. Okay, so maybe I'll just ask you part of it. I don't know, but you're going to have to know the whole thing. Okay, know the whole thing. I'll figure out what part I ask you. All right, you all got time because you got this good hour and 20-minute block. It's that 55-minute class that would struggle with that, wouldn't they, for time? All right, so you all see what's going on with that stuff there then. That's what I wanted you to notice. Let's go back over here. All right, so in this section, they introduce the trig functions, the actual trig functions themselves in this section. And you all probably heard of the trig functions before. But let's put them up here, okay? When you're studying trigonometry, you're studying the ratios of the sides in a triangle is what you're actually looking at. Trigonometry has a lot to do with these triangles, you know, and I've already drawn triangles in here today in order for us to get those coordinates up there. Okay. Let's look at what we've got here. Sine is probably, I don't know, one that you all are pretty familiar with. This is how it's really spelled, S-I-N-E. I don't like how that was looking. S-I-N-E, but we normally see it as sine in here. Then we have cosine. These two things, they're called cofunctions because one has co in front of it. How about that? That helps us know something for later. Okay, so I'll go ahead and put that out there. We use COS for cosine. It still is cosine. We don't say sin. We don't have any sin in this class. Okay, it'll be sine. Sine, cosine, tangent, and cotangent. They're also cofunctions. And that's just some terminology there for us as well. Tangent is going to be T-A-N, tan, and cotangent is C-O-T. Secant and cosecant, they're also cofunctions. Basically, a cofunction is when we have the trig function and then we put co in front of it. Okay? They become what we call cofunctions. That's all I really have to say about that, at least today. So secant is SEC, cosecant is CSC. We want to keep these things kind of straight in our heads here. So on a unit circle, now I mentioned on the first day that on the first day I said, you know, a lot of you have probably used SOHCAHTOA before. You know about SOHCAHTOA. This is going to work very similar to that stuff. So if you know about that, you're in good shape. But on the unit circle, and in fact, on any circle we can draw. Okay, not just the unit circle. We're using the unit circle right now. But the sine is going to be our y-coordinate that goes along with that terminal side of the angle. Those coordinates we were just looking at, y over r. Y over r. And the cosine is going to be x over r. Now, in a unit circle, let me move this part over just a little bit. In a unit circle, what was the radius? Radius was 1. So in a unit circle, the sine of an angle, I'll put an angle theta, the sine of an angle theta in a unit circle is going to just be y then, isn't it? The y-coordinate, because the radius is 1, so it's going to be y over 1. And the cosine is just going to be the x in that unit circle. So you already know something about the trig ratios for these angles we've already put up here in the unit circle today. We know, what do we know here? Let's go over here. We know the sine of 30 degrees and the cosine of 30 degrees. Because on our unit circle, where we had 30 degrees, we saw out here that the coordinates that corresponded to that were square root of 3 over 2, 1/2. All right, so the sine of 30 degrees would be what then? 1/2 over 1. So it's just going to be 1/2, right? 1/2 over 1. The radius equals 1. So 1/2 over 1 is just 1/2. And the cosine is going to be square root of 3 over 2 over 1. Cosine is x over r. Sine is going to be y over r. We're looking at ratios of the sides, okay? The ratio of the side across from the angle over that hypotenuse. In some cases, in the side next to the angle over the hypotenuse. What do you know about opposite and adjacent? Well, you've seen it before, I bet. Some of you have seen it before, maybe I should say. Okay. If you're familiar, I'm just going to put this up here a minute. They don't talk about this in your textbook until later on, but I'm going to put it up here. That SOHCAHTOA business. That's where you learn that the sine of an angle is equal to the opposite side over the hypotenuse, right? Some of you remember that stuff? So the sine of 30 degrees here would be equal to the opposite side. That's this side right here. What's the measure of that side? It's 1/2 because it's my y coordinate. So it's 1/2 over, what's my hypotenuse? 1. In the circle I was looking at, though, up here, that was my radius, and that was still y, so that was y over r. See the connection here? Y over r, it's still going to be the that opposite side over the hypotenuse. Okay, you can kind of hook those together, those concepts, if you have had that before. If you have not, then learn it with me on the unit circle right now. Okay. So this is a side note here. A little bit extra stuff for today. All right, let's go back to the screen preceding this and put up the other ratios at least, so we'll have those ratios and we can start getting those in our head a little better. The tangent. Tangent is going to be y over x. When you did tangent with right triangles, if you did that before, you used opposite over adjacent. The side opposite our angle here is the y. The side adjacent is the x value. If you can get these three main ones, the sine, cosine, and tangent, then you know the other three, because the other three are all reciprocals of these three. So if you've got the top three, then you've got the rest. Cotangent is going to be the reciprocal of the tangent. So to note that, I'm going to put 1 over the tangent of an angle. Okay? So 1 over the tangent, that's going to be x over y. That's going to be the reciprocal, x over y. The secant is going to be the reciprocal of the cosine. What's the reciprocal of the cosine? R over x. And the cosecant is going to be the reciprocal of the sine. That's going to be r over y. Those are our three main ones there. Then we'll have to remember about reciprocating to get the others. Okay. All this is in your textbook, by the way. This list is laid out on page 374 in the book over there. And yeah, they're wanting you to find what we call exact values. Exact values come from things like, we'll leave things square root of 3 over 2. That's an exact value. An approximated value would be what we get if we put it in our calculator and round it off. I want to give you some practice problems to work with between now and Tuesday. That's a long time between now and Tuesday. You got a lot of time to work on a few things here. The practice problems are homework practice here. Now, I don't take this up, but I want you to do it. Okay, I want you to work on it and at least make sure you know what we're doing in here. Come in, that way you can ask some questions on Tuesday at the start of class. I'll give you a chance to ask some questions about these problems. So homework practice. Section 6.1 was over on page, let me find where it went. I had it down here a while ago. Page 360. Let's try, we're converting here degrees to radians, radians to degrees, working with the formulas. Oh, not exactly 35 to 89. I take that back because I don't want you to do the calculator things right now. 35 to 57 odd and 71. You can work with 71 to 89 odd. Now here's the deal. If you start working the problems, you say, I'm getting these right. I'm giving you odd problems so you can check them in the back of the book. I don't want you to sit around and do something wrong all day. So if you see you're doing it wrong, you probably just ought to stop and try to figure out, why am I doing this wrong? Remember on My Math Lab, there's some little tutorial help for each section as well. Hopefully we're getting registered on the My Math Lab. I didn't look before I came in today. So let's try to get registered on that too. I still don't have the assignment set up there for you. I'll get one set up there pretty soon since we've gone through most of 2 sections today. Section 6.2, over on page 375, starting there. Let's work with 13 to 19 odd. And then let's see what you can do. We didn't talk so much about this, but it comes from that unit circle business. Use that unit circle I posted for you. 31 through 37 odd. We'll still have to talk about some more things in this section 6.2 when we come back on Tuesday. We're not quite finished with that section. It's a little bit longer. So does anybody have any questions today before we finish up here? Okay then. You all have a great day, okay? I'll see you back Tuesday.